Our lesson for today is all about polynomial function, which is denoted by p of x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus, and so on, up to a sub 1 x raised to 1 plus a sub 0, where a sub n must not be equal to 0. On this notation, a n x raised to n is considered as the leading term. Which contains n. And n here serves as the highest exponent. Okay? Where we can say that n here will be the degree of our polynomial function. A sub n here is what we call the leading coefficient. The leading coefficient. Now, let's put this knowledge into a test. We have here, it says, identify the leading term, degree, leading coefficient of the given polynomial function, then arrange it in standard form. By the way, when we say standard form, it means that the degree or the exponent of a given polynomial function is arranged in descending order, meaning the exponent must be from highest to lowest. Let's do this. Number 1, we have here f of x equals 3 minus 12x plus 3x squared. What is the leading term? The leading term is containing the highest exponent of the variable. For here in this given, the leading term is 3x squared. Since 3x squared is the highest exponent of the given variable. Now, what is the degree? The degree is 2. Since the highest exponent that we have is 2. What is the leading coefficient? The leading coefficient is the coefficient of the leading term. The leading term is 3x squared, so therefore 3 is the leading coefficient. Now, it says here, arrange it in standard form if possible. Notice that this given is not in standard form because the one that's on the right, on the leftmost corner, is 3. Okay? Which means the constant. Therefore, we need to arrange the terms in descending order. So that will be, we start with the leading term. That should be 3x squared. The term next to 3x squared is the term with the degree lower than the leading term. In that case, it will be 2x. Then, lastly, plus. Remember, the sign must follow the term on its right. That's why we have here 12x. Let's work on number 2. We have here 5x cubed over 2 minus 7 over 2 plus 10x squared. In this case, we are going to get rid of this denominators by simply multiplying the function Now let's work on example number 2. Here, the leading term is obviously 5x cubed over 2. the leading or the degree is 3. It's because of this cube. The leading coefficient is 5/2. And when we arrange this in standard form, it will be the f of x equals 5x³ plus 10x² minus 7/2. And that's it. That's the standard form. How about number 3? On this case, our given is in factor form. Therefore, we need to multiply the given so that we can have our polynomial function. So, x times x² is x³ by distribution property. Then x times -5 is 5x. And as you notice, it is already arranged in standard form. Now, what is the leading term? The leading term is x³. What is the degree? That is 3. Okay? And the leading coefficient is 1. 1 because there's always an invisible 1 in front of our x³. And that is how to identify leading term, degree, leading coefficient, and to arrange it in standard form. Let's proceed to the second part of our video. It is graphing polynomial functions using X-Intercept. Before we proceed, X-Intercept means that it is the value of x if the value of y is 0. For example, we have a given equation y equals 2x plus 3. If we're asked to find X-Intercept, we simply equate y to 0. We're going to equate y to 0 and solve for the value of x here. Okay? We transpose 3. So it will be -3 equals to x. And we divide both sides by 2. Our answer will be -3/2 equals, and the X-intercept will be -3/2, 0. This is our X-intercept. Now, we are going to do that on our polynomial function. In our example number 1, it says, sketch the graph of p of x equals x plus 4 times x plus 1 times x minus 1 squared. In this case, our given is already in factor form. Therefore, we can already equate this to 0 and find the X-intercept. First step, we let p of x equals to 0. The equation will be written as 0 equals x plus 4 times x plus 1 times x minus 1 squared. Applying the law of zero product property, we can get here x plus 4 equals 0, x plus 1 equals 0, and x minus 1 equals 0. We equate each factor to 0. This is the application of the zero product property. Then we solve for x, x here is equal to negative 4. We use addition property of equality, or in some other case, they're saying they're using transposition. Here, x equals negative 1, and here, x equals positive 1. Notice, we already have the values of x. What will be the x-intercepts? The x-intercepts are negative 4, 0, negative 1, 0, and 1, 0. By using these points, we can start sketching the graph. But this is not enough. We need to know how our graph moves, where our graph is going. So we need to know the movement of the graph from these points. How can we do that? We are just going to line them up from lowest to highest. We have negative 4, negative 1, and 1. We're going to get some points between them by using a number line. Okay, let's say this is negative 4. Then we have negative 1. Let's say we have here 0 and then 1. Those are our x-intercepts. We are going to get some values in between these values of x-intercept. First, let's have a value which is less than negative 4, so that we can know the trend from the left side of negative 4. And obviously, we can use the nearest integer, which is negative 5. Here, between negative 4 and negative 1, we can choose either negative 2 or negative 3. In our case, we're going to use negative 2. Let's use this. In between negative 1 and 1, obviously, we can use 0. And then, on the right side of 1, we can use positive 2. We're going to use all these 5 numbers or values to know the trend or the movement of our graph. So how can we do that? We are going to substitute these numbers into our function. And then, we need to know the sign of the answer, so that we can say where does the graph tends to move. Let's do that. Let's use negative 5. We have x equals x plus 4 times x plus 1 times x minus 1 squared. Let's substitute for negative 5 rather. So negative 5 plus 4 times negative 5 plus 1 times negative 5 minus 1 squared. Negative 5 plus 4 is negative 1 times negative 5 plus 1 is negative 4. Then, negative 5 minus 1 is negative 6. And this is squared. Take a look at this. Negative 1 is negative. Negative 4 is negative. Negative 6 squared is positive. Okay? When we perform multiplication on this side, we have negative times negative, that is positive, times another positive, that will be positive. Therefore, the sign of our answer here is positive. We don't care about the exact value. We're just caring about the sign of the answer. That is positive. Therefore, if the sign is positive, meaning the graph tends to go upward. Okay, well, let's go back in here. The graph on the left side of -4 tends to go upward. How about in between -4 and -1? Where it's going to do the exact same thing. We replace this by -2. We substitute -2. -2 plus 4 is +2. -2 plus 1 is -1. -2 minus 1 is -3. The sign of 2 is positive. The sign of -1 is negative. Here, -3 squared, it is positive. So if we're going to multiply these three signs, positive times negative times positive, it will give us a negative sign. What does it indicate? The trend of the graph in between -4 and -1 is downward. Okay, 2 more to go. How about in between -1 and 1? We're going to use 0 on that case. So if you substitute 0 on our equation, let's substitute 0. That is 0 plus 4, 0 plus 1, and 0 minus 1. 0 plus 4 is positive 4. 0 plus 1 is positive 1. And 0 minus 1 is negative 1. The sign of 4 is positive. The sign of 1 is also positive. The sign of -1 squared is positive. So when we multiply all these three positives, we're going to get a positive sign. What does it mean? The trend of the graph in between -1 and 1 is upward. And last, we're going to substitute 2 to know the final trend of the graph on the right side of our graph. Lastly, we substitute positive 2 on our equation. 2 plus 4 is 6. 2 plus 1 is 3. 2 minus 1 is 1. Where? The sign of 6 is positive. The sign of 3 is also positive. And the sign of 1 squared is also positive. Therefore, our graph here is positive. Now, since we already have the trend of the graph and the x-intercepts, we can now sketch the graph of our function. So we write our x-axis and our y-axis. Then we label it 1. Then we have here -1, -2, 3, 4. We plot each of our x-intercept. So we have -4, 0 here. Our -1, 0 is here. And our 1, 0 is here. Notice that in our given, x minus 1 is squared. Therefore, it has a multiplicity of 2. What does that multiplicity mean? It means that the graph tends to go flatten as it reaches our 1, 0 point, because there's a multiplicity of 2. There's not, it will just be running on that particular point. That's graph. So, on our left side of the negative 4, the graph is upward. Okay? It's upward. Okay? And in between negative 4 and negative 1, it's downward. So we can say it's downward. Downward. Then, in between negative 1 and 1, upward. And the right side of 1, it is upward. Now, let's sketch this graph. We're going to put curves on it. Okay, so we have it here. Then, downward. Okay. Possibly going upward and at some point going downward here. And lastly, since you have multiplicity of 2 here, you're going to tend to flatten. And there we go. The graph of our function p of x equals x plus 4 times x plus 1 times x minus 1 squared is this. Let's proceed to example number 2. Let's proceed to example number 2. Sketch the graph of y equals 2x cubed minus 7x squared minus 7x plus 12. In this case, we need to factor this first before we get to X-Intercept. So how do we factor? We're going to use the rational roots theorem. Here, in the rational roots theorem, we need to identify the factors of q, which means the constant of the given function, and p, which means the leading coefficient. Our q here is 12, the constant, and the factors of 12 are positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 12. P is 2. The factors of 2 are positive negative 1 and positive negative 2. And for us to complete this, we need to get the value of q, the values of q over p. Q over p, so the values of q over the values of p. So 1 over 1 is positive negative 1 again. 2 over 1 is positive negative 2. 3 over 1 is positive negative 3. 4 over 1 is positive negative 4. 6 over 1 is positive negative 6. 12 over 1 is positive negative 12. And we repeat, 1 over 2, positive negative 1 half. 2 over 2 is 1. 3 over 2. So positive negative 3 over 2. 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. So these are the possible roots of our given function. If we get those roots, we can convert into factors and get the X-intercept. Okay, so the next step is we need to divide our function into a certain roots here, or possible roots here. Let's use the most simple. We have 1. So we're going to use synthetic division here. So we use 1, and then we line up the coefficients. So we have 2, -7, -7, and 12. Remember, by the remainder theorem, we need to get a 0 for us to tell that this 1 here is a root, and perhaps X-intercept of a given function. So let's compute. To bring down 2, 2 times 1 is 2. -7 plus 2 is -5. -5 times 1 is -5. -7 plus -5 is -12. -12 times 1 is -12. 12 minus 12 is 0. Since the remainder is 0, we are now sure that 1 is a root. Okay? So means the roots, or the values of x, we have 1, positive 1. The remaining here can be written as 2x squared minus 5x minus 12. And by this case, we can now factor this as a trinomial. So we split this into 2, we have 2x and x. And we need to get the factor of -12 in combination with the factors of 2 to get the middle term. Okay? The factors of 12 are 3 and 4. Also 1 and 6. So let's try 3 and 4. I have positive 3 and positive 4 because -3 times positive 4 is -12. Let's see if we get the correct factors. -3 times x here is -6x. Negative 3x rather. 2x times 4 is 8x. So, -3 plus 8 is positive 5. We need negative. So, we need to interchange the sign. Let's try it again. 3 times x here is 3x. 2 times -4 is -8x. -3 minus 8 is -5. So, we are now sure that these are the factors. Getting the factors, we can have the X-intercept, or the values of x here. We just equate this to 0. So 2x plus 3 equals 0. 2x equals -3 by transposition. Our value of x here is equal to -3 over 2. Here we have x minus 4 equals 0. Therefore, x equals to 4. So, the values of x here is, we have -3 over 2, and after getting the roots, we can say that the x-intercepts are 4, 0, -3 over 2, 0, and 1. Let's proceed now in finding the trend of this given function. We have now the x-intercepts, -3 over 2, 0, 1, 0, and 4, 0. We need now to get the trend of the graph on each part of our graph. So again, we write a number line, line them up. So we have negative 3 over 2, we have 1, and we have 4. Then we're going to choose a value in between them. So the value in between negative infinity up to negative 3 over 2, we can use negative 3 over 2 is negative 1.5. So we can use 2, negative 2. Between 1 and negative 3 over 2, the nearest here we can use 0. And here we can use 2. And here on the right side, up to positive infinity, we can use 3. So let us now plot the trend of our graph. Okay? Let's substitute. It's much better to know or to substitute on the factored form rather than the standard form. So let's substitute. We substitute negative 2. Let's use the factored form. So y equals 2x plus 3 times x minus 1 times x minus 4. Remember, we just need to get the sign, not the exact value of y. So 2 times negative 2 plus 3 times negative 2 minus 1 times negative 2 minus 4. Negative 2 times negative 2 is negative 4 plus 3. Negative 2 minus 1 is negative 3. Negative 2 minus 4 is negative 6. Negative 4 plus 3 is negative 1 or negative. Then negative 3, the sign is negative. And negative 6, the sign is negative. So, negative times negative is positive, times another negative, it is negative. Therefore, the trend of the graph on the left side of negative 3 over 2 tends to go downward. How about in between negative 3 over 2 and 1? So, substituting 0 on our equation, 2 times 0 is 0 plus 3. 0 minus 1 is negative 1. 0 minus 4 is negative 4. 0 plus 3 is positive. Negative 1 is negative, negative 4 is negative. This is positive times negative. It will give us a positive sign. Therefore, the trend of the graph is upward. How about in between 1 and 4? We can use 2. So, substituting positive 2, 2 times 2 is positive 4. 2 minus 1 is 1. 2 minus 4 is negative 2. 4 plus 3 is positive. 1 here is positive. And negative 2 here is negative. Multiplying these three signs, we will have a negative sign. Therefore, this is downward. And lastly, we can use 5 to identify the trend from 4 up to positive infinity. So using or substituting 5, 2 times 5 is 10. 5 minus 1 is 4. 5 minus 4 is 1. 10 plus 3 is 13, positive 13. 4 is positive, and 1 is also positive. Gives us a positive sign. Therefore, the trend here is upward. Let us now proceed on sketching the graph using these informations. So, we're going to write our x-axis and our y-axis. Let's have here as 1, 2, 3, and 4. And we have here negative 1, negative 2. Okay. Negative 3 over 2 is negative 1.5. So it's somehow or somewhat here. That is our negative 3 over 2. 1, 0 is here. And 4, 0 is here. Let's show the trend. So from negative infinity up to negative 3 halves, the trend is downward. Between negative 3 over 2 and positive 1, the trend is upward. It is upward, and then upward. From positive 1 up to positive 4, the trend is downward. And lastly, from positive 4 to positive infinity, the trend is upward. Time for us to use some curves to connect. Okay, we start from here. Okay, and then we're going to connect this 2 with a curve. Okay, and this. And going to this is now the possible graph of our function y equals 2x cubed minus 7x squared minus 7x plus 12. Thank you for listening and hope you learned something. This is Sir Odie. See you next time.